In the ambiguous case of the law of sines, we can either calculate how many triangles we're going to have, or we could just proceed as if there are two triangles by taking the first angle that we find and using it as a reference angle in quadrant 1 or quadrant 2. Let's see what that looks like. Let us do an example. Let's say that my angle alpha is 30 degrees. Let's say my side C is 10, and the side opposite the given angle A is equal to 8. We can figure out how many triangles that we are going to have by looking at the height of this triangle and comparing the side opposite the given angle to the height. In this case, the height of the triangle is C times the sine of alpha. So 10 times the sine of 30 degrees, which is 5. The side opposite the given angle is greater than the height, but less than the other given side. So we're going to have two triangles. So we did not save ourselves any calculations. Well, so the side opposite the given angle is greater than the height, but less than the other given side. So therefore, there are two triangles. We don't have to know that going in, but sometimes we want to know going in. So I have alpha, A, and C. Since I have alpha and A, that tells us that we're going to use the law of sines. Since I have another side instead of another angle, that tells us that we have the ambiguous case of the law of sines. So let's proceed and find gamma using A and alpha. So we're going to be using this one here. I have A and alpha, I have C, so I can use this to find gamma. That's our only choice. So gamma is going to be sine inverse of C times the sine of alpha divided by A. Then we're going to grab our calculating machine. Even though the sine of 30 is a half, I give myself the easy one, and we'll just type it like we see it. Sine in, let's make sure that we're in degree mode. Sine inverse of 10 times the sine of 30, close parentheses, divided by 8, close parentheses. So gamma is a 38.68 degree angle. Let's call it 38.7. We know that there are two triangles, or we suspect that there might be two triangles if we didn't do the height calculation. So I'm going to take this gamma and say 38.7 degrees, that's our quadrant 1 angle. Now I'm going to put that 38.7 degrees as a reference angle in quadrant 2. So I'm going to do 38.7 in quadrant 1 and quadrant 2. So the calculation splits. I've got a gamma in quadrant 1 of 38.7 degrees. Then over here, I'm just going to write another gamma in quadrant 2 of 180 minus 38.7. $141.3. Problem just doubled in size. Now that I have alpha and gamma, two versions of gamma, I can calculate two versions of beta. Once we have two angles, we can subtract to find the third angle. Over on this side, I can calculate beta. I'll call it beta 1, because I have two of them. It's going to be 180 minus 30 minus 38.7, 111.3. And then over here in gamma 2, I'm going to have another beta. It's going to be 180 minus 141.3 minus the 30 degrees. And so that's going to give us, what, 8.7? You can see how easy I'm making my life by giving myself alpha equals 30 degrees. Now that I have beta, I can use beta to find B. I can actually use C and gamma, but this gamma has been rounded off, so we're going to prefer to use the given information. So I'm going to use B. I'm going to find B using A and alpha. So I'm going to find B using A and alpha. So B is A times the sine of beta divided by sine of alpha. The double asterisk is up here. B is A sine beta divided by sine alpha. And we'll just type it like, write it like we're going to type it. So we have 8 sine of alpha. All right. A sine beta divided by the sine of alpha. 14.9. That's only for the quadrant 1 version of things. Now I've got to go over to my quadrant 2 version of things and repeat this calculation, but with this 8.7. Other B, oh, so this would be B1, let's say, and this would be B2. I'm going to do 8 times the sine of 8.7 divided by the sine of 30. So second entry, and just take the 111.3 and trade it for an 8.7. We ended up with two triangles because the side opposite the given angle was greater than the height, but less than the other given side. Is everybody okay? The way we proceed is if there are two triangles, or if we know that there are two triangles, is take the first angle that we find with the law of sines and use that as a reference angle in quadrant 1 and quadrant 2. The reason that we are doing this is that quadrant 2 angles will fit in triangles. So I had a quadrant 1 angle gamma of 38.7, and that gave us a quadrant 2 gamma of 141.3. That's a very big angle, but it still fits in a triangle. Okay. I'll be like super stoked on it like this. It's because there's no class on Thursday, but it's not Thursday right now. Thinking about Thursday. So this raises the question, what if we forget to check the height? You don't have to worry about checking the height. The triangle, the numbers will tell you what the situation is. The numbers will let you know what's going on. If you just try to proceed, then the numbers will let you know what's happening. So for example, let's suppose that I say that alpha is 30 degrees, side C is 10 units, and side A, the side opposite the given angle, is only 4. You might remember that the height is 10 times the sine of 30, so the height is 5. And right now, the side opposite the given angle is less than the height, so there is no triangle. So the referee would be like, oh, this is the symbol for no triangle. I think that's also the symbol for no, not a catch or whatever. What is it? Yeah. Yes. So the big idea is that, let's draw a picture just using this. The big idea is that there's an angle of 30 degrees. And I'm saying, here's the angle alpha, and here's side C is equal to 10. Side A, the side opposite the given angle, has to go from here down to this, the side where B is going to go. That's where the third side goes. I've got to make sure I can make that connection. There's a minimum amount to cross that distance. I have to be able to have a side opposite the given angle has to be at least the height of this triangle. So if I make the side opposite the given angle too small, I won't be able to make a triangle. If I make the side opposite the given angle just right, I can get one right triangle. The one we had last time, the side opposite the given angle was greater than the height, but less than the other given side. So we can make a triangle over here and a triangle over here. We were able to do this. Where we had a quadrant 1 gamma. Or over here, this is a quadrant 2 gamma. Now, if the side opposite the given angle is bigger than the other given side, then I can't, then when it swings around over here, it just misses that angle entirely, goes all the way around, and we only get one triangle. So those are the 4 things. The side opposite the given angle, less than the height, no triangle. Side opposite the given angle, less than the height, no triangles. If the side opposite the given angle is exactly equal to the height, That's when we have one right triangle. In the previous example, the side opposite the given angle was greater than the height but less than the other given side. That gave us the two triangles case, our favorite. And finally, if the side opposite the given angle is greater than the other given side, we're back down to one triangle. That's why one shows up twice. 0, 1, 2, or 1 triangle. That's correct. So the height is always the other given side. I'm sorry, color coding things. Take the other given side, multiply by the sine of the given angle. In this case, that would be c times the sine of alpha. You know it's c times sine of alpha because the angle is alpha, and I wouldn't do a times the sine of alpha because in the law of sines, a doesn't get multiplied by the sine of alpha. They're on different sides of the fraction. Always think about the structure of the law of sines. Alpha and a, always on opposite sides of the fraction. So in this case, the other given side, it's going to be, since the given angle is a 30, the other given side is the 10. So I'd take the height as 10 times the sine of 30 degrees. Which is 5. So the height is 5. In this case, the side opposite the given angle, 4, is less than the height, so there is no triangle. Ruling on the field, no triangle. At this point, if we had checked the heights and compared the side opposite the given angle to the height, we find there are no triangles. We are done. We just say 0 triangles and move on to the next problem, or with our lives in general, which I guess is to the next problem. But it's possible that we forgot to do this. What happens if we forget to do this? Then we would proceed with the law of sines, and the numbers will let us know that we don't have to go any further. We would try to find gamma. It's like, oh, I forgot to check the heights. So I'm going to try to find gamma. And I'm going to do the sine inverse of c sine alpha divided by 4, divided by a. So I'll try to find the sine inverse of 10 times the sine of 30 divided by 4. And when I hit enter, I get an error, a domain error. There is no angle with a sine inverse of 1.25. 10 sine 30 is 5. 5 divided by 4 is more than 1. Sine is never bigger than 1. So at this point, we say, hang on, did I do that calculation correctly? 10 sine 30 divided by 4 And then I thought, yeah. So since we got a domain error and we did the calculation correctly, that's when we say, ah. You don't have to actually say, ah. It gets really annoying during the test. I used to make everybody say that, but it happened at different times. So since we got a domain error when we tried the calculation, that's when we entered in the calculation correctly, we can conclude that there are 0 triangles. Any questions? So your calculator will remind you, but you have to know how the calculator will communicate that to you. If you get a syntax error, that's on you. You're typing things correctly and your calculator doesn't understand what you said. Domain error means we're trying to find an angle with a sine inverse of 1.25. If the side opposite the given angle is less than the height, then the height divided by the side opposite the given angle will be greater than 1, and no angle has a sine greater than 1. In a right triangle, hypotenuse has to be biggest. How's everybody okay? Stoked, I see. I'm assuming that's what you look like. New rule in California. Community college students will be paid a living wage to attend school. I see you're all very happy. You will also get health insurance, including dental and vision. I'm just assuming that's how you agree. That's my plan, by the way. Well, how are we going to get money for it? Apple's going to pay for it all. I'm like, oh, really, Apple? Is that true? I'm like, oh, yes. Tim Cook, is that the guy? Come here and let the students know that's what you offered to do of your own free will. And I'm standing behind my hands on his shoulder, my hands with this guy. Tell him, Tim. He's like, well, yes, I'm doing this of your own free will. Tell him now. Of my own free will. We could have done this the easy way, Tim, but no. I had to hide all your money offshore. And now we're doing it this way. Just kidding. Calm down, Tim Cook. Bezos is good. I'm just kidding. It's happening all at the same time. All right. That's all beside the point. Let's practice. Let's take a break. Come back at 2, and then we will practice on some problems.